Hello, everybody. Let's talk about Unit 8 and Topic 2. This is applications of distance and slope formula. So what we're going to look at is just using these formulas within the context of a problem. So here I have example 1, coordinates of triangle ABC. And you see I already kind of drew, I plotted the points A, B, and C on my grid, and I connected the points to make the triangle ABC. And so what I have to do in part A, it asks me to classify this triangle as equilateral, isosceles, or scalene. Now, taking you back here a little bit, you might need to remember how or what these words mean. These are the 3 different ways that you can classify a triangle based on the lengths of its sides. And so if I want to classify the triangle based on the lengths of its sides, then I want to find the length of each side. So if, in order for me to do that, length means distance. So I'm going to find the distance of the from point A to point B, the distance from point B to point C, the distance from C to A. And so I would use the distance formula, or I could do Pythagorean theorem. So in this case, since I'm on the grid, I'm going to use Pythagorean theorem, but you have a choice to use distance. And let me show you what that will look like. Okay, so a lot just happened right there, but I tried to color coordinate here, and you see I chose to use Pythagorean theorem as an approach to find the length of each side of this triangle ABC. And so to use Pythagorean theorem, I'm going to kind of create the horizontal and vertical side that connects points A and B together. So I connected the horizontal length 2 with the vertical length 3, and then so when I'm using Pythagorean theorem and it's a squared plus b squared equals c squared, then when I'm solving for the length of that hypotenuse, I have to say c is the square root of a squared plus b squared, which if you paid attention going through that first activity, that's exactly where the distance formula comes from. It's a squared plus b squared that gets you that distance. Okay, so to find the distance from A to B, I did the square root of 2 squared plus 3 squared, that's the square root of 13. Then from B to C, that's the square root of 4 squared plus 6 squared is the square root of 52. And then from C back to A, this is the square root of 7 squared plus 4 squared is the square root of 65. So now, when I'm classifying this triangle as either equilateral, isosceles, or scalene, again, this is based on the lengths. So I found the length of each side. Equilateral would mean that each length is equal. The equilateral means sides. Equilateral is equal sides, so it's definitely not equilateral. I think you should remember isosceles, that isosceles means that you have exactly 2 sides that are equal in length and 1 side that's not. Well, I have no sides equal in length, so it's not isosceles. It's instead scalene. Scalene means that there are no sides that are equal in length. So that's exactly what I have for this question. Okay, now by doing that work, I can very easily do part B, which is find the perimeter of this triangle. So perimeter means find the sum of all 3 sides. So all I need to do is this. So just adding the lengths, and I said that the perimeter is about 18.88. That's rounded to the nearest hundredth. Okay, so there's using distance to apply to finding what type of triangle it is and also finding the perimeter of that triangle. Okay, now I'm down here to part C. It says prove angle B is a right angle. Okay, so now if I want to prove that an angle is a right angle, that means that the lines that made angle B, that's the line from A to B and the line from C to B, those lines must be perpendicular. Okay, so let me make a little note and then we'll think about what that means. So that means segment AB is perpendicular to BC. And if I want to show or prove that that's true, based on what I see right here, I would have to prove that I have a right angle or prove that I have perpendicular lines. And the tool that I have to do that job is slope, because with slope, you can prove lines are either parallel when they have the same slope or prove that they're perpendicular when they have negative reciprocal slopes. So I want to find the slope from A to B and the slope from B to C. So let's go ahead and do that. And I've already kind of done the work because I used this Pythagorean theorem counting method to find the lengths. So I can easily find what the slope is from A to B and the slope is from B to C like this. So if we remember that slope is rise over run, so I use the letter M for slope, the slope from A to B, rise over run. From A to B, I had to go left 2 and up 3. So I went up 3, left 2. This has a negative slope. That's a negative 3 over 2, or negative 3, or negative positive 3 over negative 2. And then also from B to C, I'm going up 4, right 6. So that's a rise over run of 4 over 6, which is the same thing as 2 over 3. So by showing this, now I just got to have to like summarize what this says about these segments. So since the slopes of AB and BC are negative reciprocals, then these segments are perpendicular, which means angle B must be a right angle. Now, I know there was one little trick that I forgot to talk to you guys about back in Unit 7 about proving when things are negative reciprocals. And that is, if you multiply these two numbers together, the product should be -1. So if you multiply 3 over -2 times positive 2 over 3, and you get -1, that means that these must be negative reciprocals of each other. Okay, so on to example 2, it says you have a square called ABCD, and the coordinates of point A are -8, 4, and point C are -4, 2. Now, I did not put any graph paper here, and that's okay. We're just going to try to draw a quick sketch and just think about what we know is true here. So we know that we have a square called ABCD, and we have the coordinates of point A and C. Now, the two things we want to do is determine the length of the segment called BD. So BD would be the diagonal across the corner, from corner to corner. We have the points A and C, so we have the coordinates of this diagonal, but not the one from B to D. So what I need to do is think, okay, well, if this is a square, that means that the diagonal from A to C should be the same or equal to this one here, the congruent to each other. And if the diagonals are congruent, then I would show that they have the same length by finding the distance of AC, and then I can use that to be the distance from B to D. So let's go ahead with the distance formula. So I'm going to find the distance from the point A to the point C. And since squares have congruent diagonals, then the distance from A to C will be equal to the distance from B to D. So I'm going to use A as my x1, y1, and C as my x2, y2 point, and I will substitute like this. So x1 was -8, minus x2 was -4. So since I was subtracting the -4, I added 4 here, and then I have a plus. Y1 is 4, minus y2 is 2, and now I shall simplify. So -8 plus 4 is -4 squared, and then 4 minus 2 is 2 squared, so that's 16 plus 4, or the square root of 20. So I just said that the length from B to D is the square root of 20. Okay, now part 2 is determine the slope of segment BD. Now, so in BD, when we're thinking slope, from B to D, that segment would be perpendicular to the one from A to C. So I would want to find the slope from A to C and then do the negative reciprocal to find the slope of BD. So it'll look something like this. So the slope formula is the difference of the y's, y1 minus y2, divided by x1 minus x2. So this would be like rise over run. So the slope from A to C would be -8 plus 4. And now the 4 is coming from this right here, because I'm doing -8 minus -4 is plus 4. And I made a mistake, so I'm going to backtrack and fix that, because those are x's and not y's. Okay, trying again. So instead, if I just subtract my y's first, 4 minus 2 over -8 minus -4, or -8 plus 4, simplifies to 2 over -4, which is -1/2. Now, I want to remember that that's the slope from A to C, not the slope from B to D. So I'm going to put a little note here, and then I want to find the slope from B to D is going to be the negative reciprocal of that, because squares have diagonals that are perpendicular. So what is the negative reciprocal of -1/2? It is +2. Okay, so I'll go ahead and put a little note here and then say this is what we got. Okay, and so on to the last question here. Says A, B, C, D, E, F is a regular hexagon. So the word regular means that all the sides have the same length, and a hexagon, excuse me, is a polygon that has 6 sides. So A, B, C, D, E, F are each one of the vertices of that. Now, I'm given the coordinates of the point B. So I have the point B here, and I have the coordinates for point C. Those points are next to each other. So B and C would be 2 consecutive points. And I want to find the perimeter of this hexagon. So perimeter means distance. And so I need to find the distance of, first of all, the points from B to C, and then I'm going to take that and multiply it by the number of sides because each side has the same length. Okay, so let me put a couple of notes here and then get to work. So I have hexagon means has 6 sides. Regular polygons have equal sides. Perimeter means I need length. So here comes the distance formula. So here's my generic form, and then here's me plugging in my 2 x values and then my 2 y values. Now I'll just simplify and find what that distance from point B to C is before I can find the perimeter. Okay, so the distance from point B to C is about the square root of 10, or is the square root of 10, rather. And so my perimeter would be 6 times that length. 6 times the square root of 10 is 6 square roots of 10, or about 18.97. So either one of those answers are acceptable for the perimeter of this regular hexagon. Okay, so there's the end of our brief notes, and now you should be ready to do your practice problems. Bye-bye.